Hello everyone, I'll be talking about the neutral and ionic count of this organometallic dimer, as well as the IUPAC nomenclature of the complex. I'm going to start with the central atoms of the complex, which are two iridium atoms. And iridium is a group 9 metal. There are three different ligands connected to iridium. The outermost ligand is pentamethyl cyclopentadienyl. That's a cyclopentadienyl with 5 methyl groups connected to each carbon on the ring. There are two different types of chloride ligands observed in the complex. The first one, shown above, is a bridging chloride ligand. It's called a bridging chloride because it connects two metal centers together. And the second one, shown below, is a terminal chloride ligand. It's called a terminal chloride because it is directly connected to one metal only. In this slide, we're going to be determining the neutral count of the coordination complex. First, the valence electron of iridium needs to be identified, which is 9 electrons since it's in group 9. And then the pentamethyl cyclopentadienyl falls under the eta 5 cyclopentadienyl group, giving it a neutral charge with 5 electrons. And then the bridging chloride's neutral charges have 3 electrons, but since there's two of them, that'd be 6 electrons. And because it is bridged between two metals, it's divided by 2, which gives us 3 electrons. And lastly, the terminal chloride's neutral charge is 1 electron. So all that can be added up to give 18 electrons, which satisfy the 18 electron count. And now we're going to do the ionic count for the same coordination complex. First, the oxidation state of the ligands are added up to determine the oxidation state of the two metals. The cyclopentadienyl has an oxidation state of -1, and all the chloride ligands each have an oxidation state of -1. Since there's two cyclopentadienyl ligands and four chloride ligands, that adds up to a -6 oxidation state. And since there's two metals, each iridium center has a +3 charge to neutralize the -6 charge. Iridium metal's electronic contribution will be 9 electrons minus a +3 charge, giving us 6 electrons. Cyclopentadienyl has an electronic contribution of 6, and the bridging chloride has an electronic contribution of 4. And since there's two of them, that would be 8 electrons. But since they're bridged to both metals, we'd have to divide that by 2, making it 4 electrons. The terminal chloride has an electronic contribution of 2 electrons. Overall, this gives an ionic count of 18 electrons. Since the iridium metals have the same groups connected to both metals in the same connectivity, the ionic and the neutral count is identical for both metals. And I'm going to attempt to name the IUPAC name of the complex as dimu chlorido bis chlorido eta 5 cyclopentadienyl diiridium 3. And here are my references shown in this slide. Thank you.